These are your 6.3 video notes. The topic today is higher degree polynomials, and we're going to basically start talking a little bit more about the visual aspects of the graph of a higher degree polynomial, and also tie into 6.2 with some equation writing in factored form. So before we do that, let's start by just talking about some terminology. Now, we've used all these terms actually off and on somewhere, even in past chapters, but usually not kind of lump them all together. It's good at one point to just tie these ideas all together. So what's the difference between a factor, a solution, an x-intercept, and a zero? And it's a real subtle difference. It's really about how you write things, not so much about that they're a whole lot different, because they're definitely intertwined ideas. Factors, of course, we've seen plenty of factors. Solutions, if we say solve, which we've done solving by factoring, you take your factors individually, set them equal to 0, and solve. If you want x-intercepts, then of course we're going to take our solutions and write them as coordinates comma 0. And 0 is kind of a little bit of a tweak on x-intercepts. We just look at the numbers themselves, which seems a lot like solutions, but we're not saying solving like we're solving an equation. Sometimes we just look at a graph and say, what are the zeros? Or what are the x-intercepts? Or both. So just some interchangeable ideas, and it's really more or less about what you're asked, how you're asked to write it. They're definitely all connected. So this question says, what are the zeros? But you can definitely go look at your graph and say, well, what are my x-intercepts, right? And that's really the same concept there. So -4, -1, and 2, -4, -1, and 2. And so instead of writing them as a coordinate x-intercept, we're just saying list out the numbers as zeros. One of the things we want to start looking at is how many times the graph changes direction. It helps understand some of the ideas about the kind of graph we have. So a change in direction is from increase to decrease. So for example, this is an increase, change to a decrease. Then down here, this is decrease, change to an increase. Those changes in direction have a name. They're called extrema. So when you're asked about how many extrema there are on a graph, it's good to compare that to the number of zeros you have, because generally speaking, this is not 100% true all the time, but most of the time, you have one less change in direction than the number of zeros you have. And graphically, if you think about it, that makes sense. Like if I'm drawing this graph and I got my pencil on the paper and I've got to get through the 3 zeros with a smooth curve, I got to change direction to get to that one, and I got to change direction to that one. So 3 zeros typically would mean 2 changes in direction. The general rule is at most 1 less extrema than the number of zeros. So that's basically what I'm describing here. It takes 2 changes in direction to get through 3 zeros. And there are some exceptions, but for the most part, that's going to be true. Okay, again, we're just visually today just looking at the graphs, trying to interpret what we see if we can list some of the things, tie it to degree, and look at the overall picture of polynomial. So y-intercept, again, clearly we should all have that down. Now here we change the question to x-intercepts instead of zeros, but you know it's going to be the same idea. So there's the zeros, I have those off to the side, but if I write them as x-intercepts, then I want to do them as coordinate comma 0. Interchangeable concepts. The question of degree, the lowest possible degree, well, if you remember earlier sections in chapter 6, we talked about the number of zeros being tied to the degree. And so 3 zeros definitely means a third degree polynomial. So when you ask that question, really it's another way of saying what degree function do we have. And then write the polynomial. This takes us back to 6.2, where we got to jump through a few hoops. We start out by listing our 3 zeros, or how many zeros we have, and our y-intercept. And then we start working off the equation. So if you remember from the last set of notes, we said get those things listed out and then start dropping them in. So there's y, x, r1, first 0, second 0, third 0, and I'm repeating that x of 0. The x and y is coming from my y-intercept. That only leaves me a to solve, so now we start flipping through the cleanup process. Once we have our a, then we go back and write. Because a is a 1, I won't put a 1 out front, but it's understood that's there. So this is the factored form of this equation. Now we could have written most of it by just looking at the zeros, right? I mean, we literally could have written this out, but the thing that we didn't have is we didn't know what a was. So we had to go through the process of finding a. But I definitely knew this already just by looking at the graph, actually. Okay, and we're going to tie this idea into a concept called behavior in just a minute. Anyway, let's try another one. So identify my zeros. So I'm trying to switch back and forth in the questions. One question zeros, the next question x-intercepts, to show you guys that it's an interchangeable concept. So if I list out my zeros, there they are. And then lowest possible degree is a 4th degree because I have 4 zeros. I'm not even asking for the y-intercept just yet. We'll put that down a little bit later. So we're kind of trying to go a little bit out of order here, but extrema. So 4 zeros takes 3 changes in direction. Extrema is just a way of saying changes in direction. So to get through those 4, there's 1, 2, 3 change in direction to get through 4 zeros or 4 x-intercepts. And that's pretty typical. Y-intercept sitting down there at -4. And then factored form, again, we got to go through the process because, yes, I could throw all the zeros in and give you most of the answer, but what I don't know is what's the a value. So I actually have most of it. I just got to do that, drop it in. So x and y come from my y-intercept. R's are my zeros. They're getting plugged in. go down through the process of cleaning up your mess. Drop in your -1 as your a value up front. And again, I could have easily just gone from this list right up here and just translate it to my function. But what I didn't know was the a, so I had to do a little side step of finding the a, which we did already in previous sections. So kind of a little bit of a repeat. The new thing is throwing in the idea of extrema and talking about the connection to what type of degree based on zeros. The last thing we're going to look at is behavior. And rules for behavior are basically talking about what the graph will eventually do. So we talk about it as what happens on its ends. So we use the word long run or end behavior. Long run or end behavior, same idea. So on the ends would be like this is the end and this is the end. Or for example, out here, what's happening here, what's happening here. So not so much in the middle area of the graph, but as you go far left or far right, what's the graph doing? And we often talk about it as does it rise or fall? You could say increase or decrease as well. So I'm going to start jotting down a couple things. First of all, based on the degree of polynomial, can you guys tell by looking at what degree is it? And we're going to use the word even and odd instead of going second, third, fourth degree. Well, I know this is an even degree because 2 zeros. And looking at the factors, 2 factors, it's even. And you guys should know that because the parabola opens up, that means a positive a, a concept we already know from the past. And down here, parabola opens down, that means negative a, a concept from the past. This is an odd function because, again, 1, 2, 3 zeros. 3 factors, 1, 2, 3 zeros. So it's odd. Now I'll talk about why it's positive in a second. This is the reverse of that. This is odd and negative. And then you can see that these kind of mirror each other, right? I've got 4 zeros, so it's even, and you notice how both sides go up. Positive a, both sides go down. A lot like a parabola that opens up and a parabola that opens down. So I think evens are fairly easy because here's the deal. All evens behave like a quadratic or a parabola. So if you have a positive a value and it's an even function or even degree, both up or both down. And actually this idea is not entirely new to us either. As negative, what that negative causes is a reflection. That's a transformation idea. So you reflect it over the x-axis. So positive both up, negative both down, and that's true for evens. So evens always behave the same way. They always behave like parabolas. Odds have opposite behavior. What I mean by opposite is they have opposite side behavior. So right and left sides do something different. And the way you remember this is we just focus on the right side. So if it's positive a, right side up, negative a, right side down, and then odd means opposite, so the other side would do the opposite thing. So positive a up, negative a down, other side does the opposite. So to kind of summarize, I think the evens you'll get down really quick because they match a parabola. The odds you got to get a little bit of, well, which one is which. But here's how we state it. So positive and even, we say the graph rises on both sides. If it's negative and even, it falls on both sides. So again, acts like a parabola. Positive and odd, rise on the right, fall on the left. That's this one, rise on the right, fall on the left. And negative will be rise on the left, fall on the right. Okay, so behavior, just one more piece of the puzzle to understanding what a polynomial graph, higher degree especially, would look like. You want to have an idea going in, here's what my graph looks like based on its behavior. So based on the behavior, like what I see, what is going on here? Well, first of all, the degree is definitely odd. Let's start with that. And I know it's odd because one side is going down and one side is going up. That's opposite side behavior. Because the right side goes down, that means my a must have been negative. So the behavior would read as, and this I can really just actually look at the graphs. If I got a graph, great. I don't even need to really have a bunch of rules memorized. Just look. Clearly it falls on the right, rises on the left. But that's what a positive, a negative and odd would tell me. Zeros, again, just list them out. There they are. Extrema. If we count our extrema, changes in direction, there are 4. Now this one's a little bit weird because it's 4 zeros and I have 4 changes in direction. What is going on there? It should be 3, we think, right? It should take 3 changes in direction to get through 4 zeros, but there's a little catch. As you're sketching along, change direction, and all of a sudden bounces right off of this, and that's something unique right there. When your graph bounces off of a 0, that's what we call a double 0. So 1 is a double 0, and double zeros always cause the bounce. And when you see a bounce, or you look at a graph that has a double 0, and I'll show you in a second, or an equation that has a double 0, I'll show you what that means. But that means we bounce, which causes us to not draw through the axis, and it gives us one less change in direction. So that's going to kind of be one of those exceptions to the rule. And then lowest degree polynomial, and then here's our function. So lowest degree in this case is 5th. And again, the reason we think about that is 4 zeros, typically what's going on with the 5th, the bounce is a double, you got to count it twice. So if somebody's going to go 1, 2, 3, 4, 4th degree, and it's 1, 2, 3, 4, 5th degree, double zero, you got to count that twice. Okay, one more problem and we'll wrap it up. So the idea on this one is to work just a little bit of the same problem we did without that. So like before, I'm going to take my zeros, list them out. Now here it says with a double zero or a double root, so I actually wrote it twice. Right, there it is again, twice in a y-intercept, and then I start going through my typical problem, right? So I've got all my information laid out. I drop it all in, cleanup process. We already went for this, solve for A. Write my equation. Now, here's the thing. Double zero, typically written in an equation, is not as listing the factor twice. I know I listed it twice here just so we could see the work, but you see how it's repeated? It's repeated. So when you go to write it as factored form, we can put it as the same factor squared, and that's typically what you want to do. So a couple things to remember just quick from a graph. If you see the bounce off of a zero, that's a double zero, you got to count it twice. And if we have a double zero given to us, we have to put it into the problem twice. And then we have to write our final equation as squared. Okay, that's going to do it for your 6.3 video notes.